Welcome everyone to another class of electromagnetic fields and wave. সবাই কি আমার স্ক্রিনটা দেখতে পাচ্ছেন এবং কথা শুনতে পাচ্ছেন ক্লিয়ার?
জি স্যার।
Okay, thank you. আচ্ছা. In the previous class, we have covered the postulates of electrostatics in free space. There was one differential form, there was one integral form. Now, we will try to build up on these two formulas and see what can we actually find today. So first thing first, one of the basic and simplest problem in electrostatic is Coulomb's law. So first we'll try to understand Coulomb's law. Sorry. Now we consider the simplest possible electrostatic problem of a single point charge q at rest in a boundless free space. এই যে দেখেন একটা পয়েন্ট চার্জ কিউ আছে বাউন্ডলেস ফ্রি স্পেস মানে এটা স্পেসের শেষ নাই in order to find the electrostatic field intensity due to q, that means we want to find the electric field and intensity due to q, that the how much electric field intensity q is producing. We draw a hypothetical sphere surface of radius q r centered at q. What does that mean? That means there is a point charge here, suppose it is q, and you have drawn a hypothetical sphere around it. Okay, though my sphere is not very symmetrical, but the charge q is in the, suppose there is a football is sphere shape, and at the center of that football there is a charge q, and you want to find the electric field intensity that has been created by q. Okay, এটা হলো আপনি বের করতে চান. We draw a hypothetical spherical surface of radius r centered at q. Since a point charge has no preferred directions, its electric field must be everywhere radial and everywhere radial. এটা মানে কি, যে এটা মানে হলো যে এই জিনিসটা ইলেকট্রিক ফিল্ড এদিকে হতে পারে, this can be here, this can be here, মানে everywhere আর কি, radially মানে radius বরাবর, and has the same intensity at all points on the spherical surface, and that has the same intensity. So as there is same intensity, that means if you find at a certain point, then you can find that the electric field intensity is same for every point. So to find for one single point is more than enough. Applying equation 3.7 to figure 3.2a. 3.7 হলো আপনার এই যে এই ইকুয়েশনটা ছিল আর কি। ওকে, এই যে this equation, integral form, this equation. ওকে, এই ইকুয়েশনটা হলো আমরা এই যে এখানে বসাইছি. So that the surface E into ds, now E into ds যেটা হবে electric field intensity. Now as you have to put a direction at the electric field intensity. Okay, what you can write, the electric field intensity is at the direction of air. Okay, we know that the unit vector in the direction of the radius air. So by this air here, you are just giving the direction. Suppose আপনি এরকম লিখছেন না, এই যে ax5 ay6, that means that the 5 is the magnitude and ax is the direction. So this is something like that. Here er is the magnitude and ar is the direction, and same goes for the surface area. It is along the air. Now there comes the q by epsilon naught. These things are from the formulas. এই যে এখানে যে ফর্মুলাটা আছে এই ফর্মুলা থেকে, ঠিক আছে? q is the enclosed charge. Now ar dot ar as dot product, they are gone, and er is the magnitude, so magnitude has come. As magnitude is a scalar content, there is no variable, as so integration will not happen to this. So now the integration is the enclosed surface of ds. Now if you remember that what is the surface area of any sphere, sphere surface area কি? The surface area of the sphere is 4 pi r square. So by integrating ds, okay, by integrating this term, we get the whole area of the sphere, and the whole area of the sphere is 4 pi r square. This is a formula. There is nothing, that we have done here. It is a simple formula we have put here. Sphere into 4 pi r square. So this ds is gone. Q by epsilon naught is there. So therefore, E equals to, E means that the electric field intensity, E, that means there has to be some direction. E is along the direction of air. So E equals to AR into ER. ER is the magnitude. So ER is the magnitude. ER equals to, if you put this value in the right hand direction, then it goes to the divide. Divide where? Down side. Okay, by dividing, it goes to the right hand direction. So E equals to AR ER equals to AR into Q by 4 pi epsilon naught R square. So this is my electric field intensity. Okay, so Coulomb's law থেকে এগুলো আসে. Equation 3.12 tells us that the electric field intensity of a positive point charge is in the outward radial direction. Outward radial direction means it's a outward radial direction. ঠিক আছে, বাইরের দিকে যায়. Outward radial direction, and has a magnitude proportional to the charge and inversely proportional to the square of the distance from the charge. দেখেন, that has a magnitude proportional to the charge. It's a magnitude proportional to the charge and inversely proportional to the square. এই যে r কি আপনার distance না, r হলো এই যে দেখেন, suppose this is my sphere, this is my charge q, and I want to find the electric intensity at this point, and this is the distance r. এই জিনিসটাই বলছে এখানে. This is what they have told. That the equation tells us that the electric field intensity of a positive point charge is in the outward radial direction and has a magnitude proportional to the charge and inversely proportional to the square of the distance from the charge. This is very important basic formula of electrostatics. এটা very simple. এখানে আসলে কোনো rocket science কিছু নাই. There is no rocket science behind it. It's very simple and straightforward. Now, as we can see that the charge is at the origin. Okay, and we have point, and now we want to find when point charge is not at the origin. Okay, when point charge is not at the origin, then we want to find out the formula. If the charge q is not located at the origin of a chosen coordinate system, suitable changes should be made to the unit vector AR and the distance r to reflect the location of the charge and of the point at which E is to be determined. Suppose this charge was at the origin. Suppose the origin is here and your charge is here. Now you need to find the electric field intensity at this point. Now আপনি কি করবেন? দেখেন origin এখানে. When origin is at this point, then you could have written the r directly, but you can't write r directly here. মানে এখন r বসাই দিলে, এই কেসে r বসাই দিলে হবে না. Now, if the charge q is not located at the origin of a chosen coordinate system, suitable changes should be made to the unit vector AR and the distance r to reflect the locations of the change of the point at which E is to be determined. Let the position vector of q be r prime. The location vector of q, এই চার্জটা q, এটার origin থেকে, from the origin the distance of q is r prime, and that of a field point p to be r. And from the origin, the charge q is at r prime direction, and the point p, the point you want to calculate the field intensity, the distance is r. As you can see, these are written in the bold form. Bold form mein likha mane ki, what do you understand when these are written from bold form? That means this is vector quantity. যেমন এখানে দেখেন, this E is written in the bold form, so it is vector quantity. This is not written in the bold form, so this is not vector quantity. Okay, আমরা অনেক আস্তে আস্তে যাব, ঠান্ডা মাথায় যাব. এখন দেখেন এখানে in this case This is very straightforward. Electric field intensity E equals to AR Q by 4 pi epsilon naught R square. What is the R? R is the distance between the charge and the point you want to find the electric field intensity. This is the distance between the charge and the point you want to find the electric intensity. দুইটার মধ্যকার দূরত্ব। এখানে দেখেন the distance between the charge Q and point E, we have to find it. How? দেখেন দেখাচ্ছি একটু দাঁড়ান, let me wipe it out. Here, suppose this is my coordinate system. This is my origin. At this point, there is my charge Q. Okay, let me draw the sphere first. Okay, now suppose this is the point. Let me draw it in different color. This is the point. I want to find the electric field intensity, suppose P. They have given me the distance from the origin to the charge, and that is R prime. They have given me the distance between origin and the point I want to find the electric field intensity, and that is R. But my matter of interest is this distance. My matter of interest is this distance. The distance between the point charge Q and the point that I want to find the electric field. This is my matter of interest. Now, how can I find it, sir? You can find it very easily from the, suppose this distance is A. Okay, this distance is A. Now, exactly. আমি এটাই দেখাইতাম। Exactly, এটাই হয়। R minus R prime. ওই যে from the triangle rule, remember? এই যে এখান থেকে গেল R prime, এখান থেকে গেল A. Suppose R prime plus A equals to R. So A equals to R minus R prime. Exactly, একদম এটাই কথা। অনেকেই বুঝছেন হয়তো। ঠিক আছে? Suppose I am taking this distance A, so A is equals to কি হবে? R minus R prime. I am getting it from the triangle rule. ত্রিভুজ সূত্র, যোগের এডিশন ত্রিভুজ সূত্র, যে triangle rule ছিল। We have discussed it in একদম first class. So now comes the part. So I know the distance between the charge Q and the point P, which is R minus R prime. Now you can see from the formula, this is R square. That means it is just the magnitude value of R to the square. This is the magnitude value of R times square. Now, whenever you want to try to find the magnitude value of any vector, what you do, you take the modulus sign. Remember, whenever you try to the magnitude, okay, ওই যে magnitude বের করছে না, suppose ওই যে root over করে 6 square plus 2 square plus 3 square. So this is the magnitude value.
Yes, sir.
I've taken the magnitude value R minus R prime square. Now, as this unit vector is not conventional unit vector. Suppose the unit vector you have put here, this is AR. This is conventional. R, theta, phi, AX, AY, AZ. These are the conventional unit vector. So the AQP is a unit vector which is going from the Q to P direction. The AQP is a unit vector drawn from Q to P, drawn from Q to P. So this AQP I need to substitute. How can you substitute? What is my unit vector? Unit vector means whenever you are dividing a vector quantity by its magnitude, you get the unit vector, isn't it? Whenever you divide the vector quantity by its magnitude, you get the unit vector. Okay, it will by definition. So the AQP, in the AQP direction, the vector is R minus R prime, and the magnitude is R minus R prime modulus. So I am substituting AQP by this. Whenever I am substituting this vector, then what I am getting, দেখেন, I'm putting this value here. Then R minus R prime will be multiplied by this, so this becomes R minus R prime cube, and here is q into r minus r. Okay, this is the electrostatic field intensity.
AQP is equal to sir R minus
আচ্ছা
R.
দাঁড়ান, ওয়েট বুঝাইতেছি একটু 2 মিনিট। Suppose 6ax, this is a vector quantity, isn't it?
Yes, sir.
Now for this vector, what is the magnitude of this vector? What is the magnitude? 6 na?
Yes, sir.
Achha. The vector quantity here is 6ax. Magnitude is 6. So the unit vector is the vector quantity divided by magnitude. So the vector quantity is 6ax, magnitude is 6. So unit vector is ax. এবার কি বুঝছেন? Unit vector is vector quantity divided by its magnitude. বুঝছেন নাকি বুঝেন নাই?
জি স্যার।
জি স্যার, বুঝতে পারছি।
এখানে এই কাজটাই করছে, এটা একটা ভালো কোশ্চেন। এই কাজটাই করছে, unit vector vector quantity divided by magnitude. They are replacing this thing.
ও আচ্ছা স্যার, ওই যে r কিউব করছে স্যার। স্যার এবার বুঝছি।
হ্যাঁ, now they put it here, so this square and this is single power, so this becomes cube and this becomes, I'm putting this value here, so I'm getting this.
জি স্যার, বুঝছি স্যার। ওই যে স্কয়ার মনে করতে সাথে কোথায় গেল এটা স্যার?
So we have completed our very first expression, which is Coulomb's law. Now we will do a simple mathematical problem. Very simple but very important. Determine the electric field intensity at P. That means this question is compatible with this graph or with this figure. Determine the electric field intensity P. That means the these P's coordinates are given. X, Y, Z coordinates are given. Due to a point charge of +5 nanocoulomb. That means they have given the value of point charge Q. At Q in the air. Okay. মানে the coordinates of this point charge, that means where this point charge is located is at this point. That means this point charge is not located at the origin. This point charge is not located at the origin. All dimensions are meters, so you have to find the electric field intensity. So this is my formula. A formula, I have to use this formula in order to find the value of the electric field intensity. Now first I need to find the R, vector R. What is vector R? What is vector R? OP. এই যে দেখেন, the vector R means OP. So vector R is OP. That means from the origin I have to write this vector. So you can see minus ax 0.2, the y term is 0, and then the z term is 2.3, so minus az 2.3. This is the R. Now R is, now we need to find the R prime. What is R prime? R prime is OQ. This point they have noted as the capital Q, OQ. OQ is equals to R prime. So OQ I'm getting is from this 0.2 AX, 0.1 AY, minus 2.5 AZ. So I'm getting the R prime. Now here we can see we need R minus R prime. So R minus R prime is, I'm subtracting this term to this term. I'm subtracting this term to this term. Biyog. By subtracting, I'm getting this value. Okay, do it at home. You will. I hope you will understand the algebraic.
ওটা স্যার কই স্যার?
হ্যাঁ
স্যার ও
হলো অরিজিন। এই যে অরিজিন থেকে
মানে
মাপতেছেন না,
কোশ্চেনে স্যার ও এর 0 0 কি স্যার সব ধরবো?
origin to 0 0 0 0 0 origin 0 0 0 always. So difference is this. Now you need to find the r minus r prime cube. That means
স্যার
first you need
আর প্রাইম স্যার স্যার 0 0 যদি অরিজিন হয় স্যার গুণন দিলে স্যার সব 0 0ই হওয়ার কথা না।
r prime দেখেন r prime কি ফিগারটা দেখেন r prime কি the distance between o and q না।
জি স্যার গুণন যদি দেন স্যার 0 সব তো স্যার আর প্রাইমের সাথে 0 গুণন দেন তাহলে স্যার 0 হয়ে যাচ্ছে না, মানে এ এ এক্সিস স্যার স্যার এক্স এক্সিস ওয়াই এক্সিস জেড এক্সিস স্যার 0 হয়ে যাচ্ছে না তাহলে।
এটা তো গুণ না, এটা তো পজিশন ভেক্টর বাইর করতেছি। ওই যে একটা অঙ্ক করাইছিলাম না, ও আর ও পি কেমনে বাইর করে।
স্যার
ওপি মানে হলো the vector is the vector distance between o and p. OQ means the vector between o and q. এখানে হলো ভেক্টর আপনি বসাইতেছেন, আপনাকে তো এখানে the point q that is given here, it is the coordinates, আপনি কোঅর্ডিনেট দিয়ে দিছে। now you have to implement in the vector। আপনি তো এটা গুণ দিতেছেন না, ও কিউ মানে কি ওর সাথে কিউ গুণ নাকি, এটা তো গুণ না।
না
OQ
স্যার
means the vector distance, so OQ means the distance from the O to the
না
Q.
স্যার ওইটা বলে নাই স্যার, ওই যে পি এর দেখেন স্যার 0.20 মাইনাস 2.3, তো পি এর তো তাহলে ওয়াই এক্সিস তো স্যার নাই।
নাই।
জি স্যার তাহলে এই কারণে বাদ দিচ্ছেন। তো আবার আর প্রাইমের ও এর এক্সিস তো স্যার ওই হিসাবে স্যার 0 0 0 আর সাথে কিউ আছে।
হ্যাঁ, তো কিউ এর মধ্যে তো এক্স ওয়াই জেড তিনটাই আছে।
জি স্যার ওইটাই হচ্ছে, আমি কোশ্চেনটা আমি করতে হইতেছি না। জি স্যার
আচ্ছা, এরপর হলো আর মাইনাস আর প্রাইম কোশ্চেন, এই দুইটা হলো বিয়োগ দিছে। এরকম একটা অঙ্ক আমি করাইছি, আপনি একটু দেখেন, প্রথম দিকে এরকম একটা অঙ্ক আমি করাইছি।
হ্যাঁ ওটা করাইছেন স্যার।
ওইটার মতোই এটা, ওইটা তো কোনো সেম জিনিস। এখন যেটা করছেন আর মাইনাস আর প্রাইম করছেন, দুইটা বিয়োগ দিছেন। এখানে কিছুই না, জাস্ট ইউ হ্যাভ এক্সপ্রেস দিস কার্টেসিয়ান কোঅর্ডিনেটস ইন টার্মস অফ ভেক্টর। এরপর জাস্ট দুইটা বিয়োগ, এখানে আর কোনো কমপ্লিকেশন নাই। আচ্ছা, দেন ইউ নিড টু ফাইন্ড দ্য ম্যাগনিটিউড। এই যে ম্যাগনিটিউড বাইর করার পর কিউব করবেন। আফটার ইউ ফাইন্ডিং দ্য ম্যাগনিটিউড দেন ইউ উইল কিউব ইট। So what is the magnitude? Magnitude is something like this. So it will be 0.4 square, 0.1 square, 0.2 square, and then whole to the power root. I also take several classes regarding magnitude, how to find the magnitude. So this is my magnitude. Now these things are very easy. Now what you have to do, you just have to put the values. You have to put the values in this formula. You can see 1 by 4 pi epsilon naught. 1 by 4 pi epsilon is 9 into 10 to the power 9. Charge q is plus 5 nanocoulomb, as it is taken as nanocoulomb. So 10 to the power minus 9, in order to convert it to the coulomb value. R minus r prime is here. Put that value, r minus r and to the power whole cube. So this 0.458 has been taken to the cubic term. So এখানে বসাইছেন, অঙ্ক শেষ, জীবন আনন্দ আর আনন্দ। নিচে আর লাগবে না, একটু করলে হবে। So this is the math and this is the procedure regarding the Coulomb's law, and we have discussed the simple math regarding Coulomb's law. Both are very important. Now I will end my topic, today's topic, with this. This is electric field due to a system of discrete charges. In the first case, in the first topic, we have find the electrostatic field intensity for a single charge. Now I want to find the electric field intensity for plural number of charges. That means more than one. So now you have to be very, concentration needs to be very high, because this topic is somehow tricky. Okay, the concentration needs to be very, very high. The formula we have generated earlier was for the single charge. Whenever you are taking the charges for more than one value, then you are starting from 1 to n. That means you need to add. What you are actually doing is, suppose electric field intensity for a point is, for one point is 2, for another point is 3, for another point is 4, for another point, what you are doing by the summation sign, you are adding all these values for each point. এখানে এই কাজটাই করছে। Now, although the equation 3.22 is succinct expression, and it is somehow inconvenient to use because of the need to add vectors of different magnitude and direction. Now, আমরা এখন একটা simple case চিন্তা করব। Let us consider the simple case of an electric dipole that consists মানে হলো যে কনভেনিয়েন্ট একটা এক্সপ্রেশন না আর কি, মানে লাইক যে এই এক্সপ্রেশনটা দিয়ে আপনি সব জায়গায় ধরেন যে ইউজ করতে পারবেন না আর কি, বুঝছেন, যে একটা ভগ এক্সপ্রেশন আর কি, যে লাইক ধরেন এই এক্সপ্রেশনটা যদি আপনি সাম ধরেন যে একটা জায়গায় আপনারা ইউজ করতে বললো, হ্যাঁ, যে একটা জায়গায় ইউজ করতে বললো যে আপনাকে এটাকে সংক্ষিপ্ত, সোজা কথায়, ঠিক আছে, যেটা একটা সংক্ষিপ্ত জিনিস এক্সপ্রেশন, সংক্ষিপ্ত এক্সপ্রেশন দিয়ে আপনি সব জায়গায় এটা ইউজ করতে পারবেন না, সব জায়গায় যাতে আপনি ইউজ করতে পারেন ওরকম একটা আপনার এক্সপ্রেশন লাগবে, বুঝছেন। তো সাকসিন্টের বাংলা হলো নরমালি বলা হলো সংক্ষিপ্ত আর কি। আচ্ছা, আসি চলেন, এখন আমি এমন একটা কেস চিন্তা করব যে দেখেন, যে কেসে there are two charges, one charge is plus q, another charge is minus q, the distance between them is d, and I want to find the electric field intensity at point P. So এখানে দেখেন একটা মজার জিনিস, ইলেকট্রিক ফিল্ড ইন্টেন্সিটি অ্যাকচুয়ালি, হোয়াট ডাজ ইলেকট্রিক ফিল্ড ইন্টেন্সিটি অ্যাকচুয়ালি মিনস, যদি এটা ভুলে যান, ইলেকট্রিক ফিল্ড ইন্টেন্সিটি অ্যাকচুয়ালি মিনস দ্যাট suppose there is a plus q charge and there is a 1 coulomb of charge, so how much repulsion that plus q charge will do is actually the electric field intensity. Okay, how
to a ds square.
For 1 coulomb of charge, how much force it will face. So for this point, I want to find the electric field intensity of plus q and minus q for this point. As electric field intensity, for measuring electric field intensity, the convention is to put plus 1 coulomb of charge in P point. That means it's a positive charge. So plus q will repel the plus 1. That is why direction is like this. And here is minus q. That means the plus 1 coulomb will face attraction from minus q. That is why the direction is here. And we want to find the electric field intensity E, which is going in this direction. Okay. Vector summation করছে। এখন দেখেন এখানে অনেক ব্যাপার স্যাপার আছে, একটু ঠান্ডা মাথায় দেখতে। Everyone, I hope that you guys remember this formula. এই ফর্মুলাটা একটু মাথায় নিয়ে রাখেন, this formula, because I will use this formula now. As you have already seen that whenever there are more than one charges, the electric field intensity is the summation for all the cases. Now, as there are two charges, that means summation for both of the cases. So then the electric field E at the point P is the sum of the contributions due to the plus Q and minus Q. Due to the plus Q and minus Q. So for the plus Q, মানে এখানে হলো কি যে এটা আমরা কি বুঝছেন নাকি এভরিওয়ান দেখেন তো, what they have done here, they have put two values. আমি একটু লেখা দেখাই তাহলে বুঝবো, একটু হোল্ড করুন, আমি একটু লিখে দেখাই। For plus q, I want to find the electric intensity for plus q. Okay, then what will be the electric field? E equals to q by 4 pi epsilon naught. Okay, now when you see here, for plus q I need to find the distance. I need to find the distance between plus q and p. The distance between plus q and minus q is the d, and this d is located at the origin. I've taken it, এখানে আমরা এগুলো ধরে নিছি। Let us consider the simple case of an electric dipole that consists of a pair of equal and opposite charge plus q minus q separated by a small distance d as shown in figure 3.5. Let the center of the dipole, এই যে দেখেন let the center of the dipole means a plus q minus q, দুইটা charge opposite and the bit of the distance very small. Let the center of the dipole coincide with the origin of a spherical coherent system. Then the electric field মানে এগুলা ধরে নিছে, these things are taken. So from this distance to the p distance is r. So from plus q to p is r minus d by 2. Okay, এটা হলো একটু বুঝতে হবে, because this distance is d by 2. This is the middle part of plus q and minus q. This distance is d by 2, this is r. So this has to be r minus d by 2. যে আগেরটার মতোই, r minus r prime এর মতো, this is r minus d by 2. So the distance between plus q and p, plus q and p is r minus d by 2. The way you have, so r minus d by 2. Now what I was doing here, that means the formula will be r, এগুলো সবগুলো ভেক্টর আর কি, বুঝছেন তো, আমি আর ভেক্টর সাইনটা দিচ্ছি না, this r is vector, everything is here is vector, r minus d by 2 divided by r minus d by 2 square, sorry, cube হবে এটা এখানে, for plus q, and for minus q e will be, এখানে আসবে কি minus q 4 pi epsilon naught. এখানে দেখেন the distance between minus q and e, between minus q and p is r plus d by 2. This is again that হচ্ছে আগেরটার মতো. So here it will be r plus d by 2, here will be r minus d by 2 cube. So now we know that in order to find the electric field intensity we need to add both of these. Okay, মানে এটা হলো ধরেন একটাও, এটা হলো আরেকটা, so e equals to e1 plus e2 আর কি. Okay, summation হবে, তো summation হলে এই যে দেখছেন তখন এটা এসে পড়ছে, they've taken the q by 4 pi epsilon naught common and এটা এসে পড়ছে, just এই দুইটা they have added these two, e1 plus e2, e will be e1 plus e2 add করছে, so এই কারণে এটার সামনে দেখেন in front of it there is a minus. Now they want to simplify this value r minus d by 2 whole cube. একটু ঠান্ডা মাথা দেখবেন, r minus d by 2 to the power minus 3, this is modulus, that means what, that means r minus d by 2 whole square, isn't it, r minus d by 2 whole square. So and then the root, ওই যে আপনারা মডুলাস বাইর করছেন যে মডুলাস ভ্যালু, এটার মতই, 2 মিনিট দাঁড়ান, আমি একটু এক্সপ্লেন করলে জিনিসটা একটু সহজ হবে, একটু দাঁড়ান. Suppose this is, I'm showing simpler terms, r to the power minus 3. Suppose this is like this. Then what you do, you put r square half, isn't it? Then this full term is enclosed with minus 3, whole to the power minus 3. That means as r square, you can write this r square as what? R dot r, same thing, r into r square, and this half is gone to this power, then minus 3 by 2. This thing both are equal. সবাই কি বুঝছেন from this term to this term কিভাবে আসলো? This is modulus, that means you need to take this r square half, এখানে এই জিনিসটাই বসে from this line to this line, বুঝতে হবে, these are very simple, from this line, simple algebra. Now they do the dot product, r dot r, that means r square, then r minus d by 2, this will be r minus d by 2, this is minus d by 2 minus d by 2, d square by 4, and plus হয়ে গেছে, this is r into d. Simple, very simple. So r square minus r dot d square by 4. Then what here they have done here, they have uh, they have taken the r cube r to the left. Okay, r বাইরে নিয়ে আসছে. So then what becomes? It becomes something like this when they take the r out of the equation. Okay, they have taken the r out of the equation. Okay, man, these are almost equal. Okay, so don't take it very to the value, because the first term on the right side of the equation can be simplified if d is very less than r. D is very small. That is why they have, they have take out the r. They have take the d, because d's value is very small. So this d square by 4 is gone. This d square by 4 is gone. This r square minus r dot d is here. Then what they have do, they have take the common term of r square. They have take common of r square. That means it has become 1, and this is r dot r divided by r square. And whenever that r square is coming out of the bracket, this has become r minus 3. You have to do it by your hand, then you will understand step by step. From this line to this line, they have, binomial expansion that you have gone through in the high school. They have done the binomial expansion here, and they have taken out the higher order terms. Ekhane onek higher order term hoche, they have taken it out. Binomial expression diben, later search koro, you will get the binomial expression. And in that binomial expression, they have taken the higher terms out, where the binomial expression has been used and all the terms containing the second and higher order of d by r have been neglected. So this whole term has been replaced by this. So they have replaced this term here. And we have done it for r minus d by 2. R plus d by 2 will be same, just there will be a minus here. Substitution equation 3.24 and 3.25 in this term, and we are getting this. Okay, this is the simplified version. You need to do many calculations in order to get that, but you have to do them. Otherwise, you will not get them. This is the expression. Then, এখানে derivation we do many, যে আমরা বাদ দেই নেই, ঠিক আছে, অনেক modification. There are many modification for this expression. Now we will come to know there is something called electrical dipole moment. What is electrical dipole moment? Electrical dipole moment is an expression. What is the expression, sir? Dekhen. Suppose there is a charge plus q, there is a charge minus q, and the distance between them is d. Then the electrical dipole moment is d into q. This is just a formula, just an expression what electrical dipole moment is. P equals to d into q. The electrical dipole is an important entity in the study of electric field in dielectric media. We define the product of the charge and the vector d going from minus q to plus q as the electric dipole moment p. So p equals to q into d. Now you can see that q is multiplied here, q into d, and then that is replaced here by p, and there is no longer the q. So this is my expression. Now where the approximate sign uthai nise for out of simplicity. If dipole lies along the z-axis in figure, then vector p equals to az into p. If you remember in the earlier class, the conversion between Cartesian, cylindrical, and spherical coordinate, in that chapter you will find that az is replaced by ar cos theta minus a theta sin theta. Okay, so r dot p has become rp cos theta. Okay, so this equation 3.28 becomes something like this. So actually there are a lot of calculations here, and these calculations you need to practice at your home with your exercise book. Then you will find to understand. Whenever this thing comes, see equation 2.77, go to the 2.77, because this book is given on your BLC. So I hope you will express these terms with the proper expressions, and you'll get this term eventually. Okay, but there are a lot of calculation. I have simplified the most of the part. Rest of the part you need to do it by your own self. Okay, so okay, thank you everyone for staying with me. The lecture is ending now. Thank you.